Hey guys, I seem to have had an issue while I was recording the lecture, but I'm just gonna provide like a shorter version of what we covered and just go over the notes. So we were finishing up with the multi-wire branch circuit. What I was explaining is that a multi-wire branch circuit, as it says here, should only supply a line to neutral loads or line to neutral loads. As we said, this would be like two single pole breakers, and then they both share the neutral. So this is line to neutral loads, and this is how the multi-wire branch circuit will supply it. However, don't forget the two exceptions that we needed to highlight. Both of those were dealing with line to line loads when the neutral can or cannot, or rather can or doesn't have to be present. Sometimes the neutral is present when we have, like for example, a 240 volt load with A phase and B phase both going to that load. But a lot of times we don't have a neutral in that situation. This would still be considered a multi-wire branch circuit. And same thing when we have three-phase systems that don't have a neutral, same thing. And this is where I illustrated the panel with the A phase, B phase, and C phase. The other thing we needed to note down was the fact that all of them have to be grouped together in the conduit. All conductors have to run through the same conduit. Remember, this would have caused the amperage on the neutral to increase versus decrease when they're both or all three, A phase, B phase, and C phase of a multi-wire branch circuit in the same conduit or ran or grouped together. If you separate those, then you have double the amperage on the neutral, and this can potentially put the neutral at risk. Also, we talked about the identification for the branch circuits. We said that the neutral, the grounded conductor, would be white, gray, or, well, that's it, white or gray, sorry about that. The grounding conductor is the one that has an or, green with a yellow stripe on it, or bare copper like you would find in the Romex. And the ungrounded conductor, as I mentioned, while there is a rule that says any color other than white, gray, or green, this note down here gives us an idea of what to do when we have multiple voltages in the building, or different, as the bottom line says down here, different systems within the same premises have the same nominal voltage shall be allowed to be identified together. However, when they don't have the same voltage, then we're going to separate those. Right? We're going to use different colors, as it says up here, where the premise wiring has branch circuits applied from more than one nominal voltage system. Each ungrounded conductor of the branch circuit shall be identified by phase or line. And this is where I was mentioning the brown, orange, and yellow for 277, 480, and black, red, and blue for 120, 208, or 120, 240 volt systems. From there, we looked at the GFCI protection article, Article 210.8. All we noted there was, just to go back to that article, is that there are going to be dwelling units and requirements for the GFCI there, and then there's going to be other than dwelling units and the requirements for the GFCI there. I was noting the fact that it uses a universal sort of common sense idea with these. Is anything like bathrooms and kitchens, which you find in both the garage, outdoor spaces, areas where people can potentially get shocked, and then the hazard of getting shocked is increased by machinery or water or something like that, then GFCIs do get placed in that situation. So this was a fairly small note, only because you just had to reference the article, and if a question comes out of there, then you'll be able to just pick out what thing it is. Like, for example, is a GFCI required in the living room? No. Is a GFCI required in the kitchen for small appliance? Yes, right, because the kitchen does fall under one of those requirements. From there, we went on to number of circuits required. We jumped over here to what is a circuit. These are all the notes where we left them. And remember, a circuit's going to have a panel, a source that power comes in. Usually it's just a panel for us. The wires sized for the amp rating of the circuit. A load, we have motors, we have non-motor loads, and then something to protect it. Overcurrent protection devices, but in our world, those would be fuses or breakers. We described after that how we're going to rate that circuit. The maximum amount of amperage an overcurrent protection device is what we call the circuit rating. This was a recommended 80% from the code book. It is not a rule that we must follow. We're not going to fail inspections because of this. However, we did get into continuous loads and non-continuous loads when we are going to determine what the total amperage of the circuit is going to be. And that way we can select a breaker that then we try to bring as close to 80% of the entire amperage that the circuit is going to require. So we're going to approach the two loads as continuous loads and non-continuous loads. We're going to take the continuous load amperage and increase it by 125%. The non-continuous load, we do not have to increase it at all. We can use 100% of the load. I gave an example where we took 12 amps continuous and multiplied it by 125%, which looks like 1.25. This gave us a total of 15 amps. We had a non-continuous load. Sorry, the 12 amps was continuous. I think I may have said non-continuous just now. So that's why we increased it. Apologize. We're going to take a non-continuous load of 10 amps and just keep that right at 10 amps for a total amperage for this circuit of 25 amps. And now, like I said, we're not going to get into breaker selection, but there is, for example, a 25 amp breaker. There is one that exists. So this would be fine to select. Now, because the amperage of these two systems here, or these two loads, is so close to 25%, then we kind of violate the 80% rule. However, it would be okay in this case because the consideration would be, will both of these loads be on at the same time and at full power? That can be a reason to consider maybe just using the 25 amp breaker. But if you moved up to a 30 amp breaker to accommodate for the 80%, this would still be within the margin of acceptable. All right, now those details get us a little bit deeper into breaker selection, which you're going to cover a lot better when you get into code C and you cover Article 240, which covers overcurrent protection devices. There's a lot of little rules there that we have to include. So for now, just coming up with the total calculated amperage of those two loads would be enough. We're not selecting breakers yet. Now, I'm going to pause right there because this side of things, I have that recording. So there's going to be another video provided in this lecture video section, which has me going through Article 210.11. So I'm going to pause it right here. And for that, the rest of this, just check out the other video.